Question 18. A solid frustum is made by removing a small cone from a large cone as shown in the diagram. So we've got this large cone and they've removed the small cone over here. The slant height of the small cone is 6 centimeters, that's on. The slant height of the large cone is 10 centimeters, and that's on. The radius of the base of the large cone is 3 centimeters, and that's on. And I can see I've got the radius of this base, but I don't have the radius of that base, so I'm going to have to find that out later. Calculate the total surface area of the frustum. Give your answer correct to 3 significant figures. To calculate the area, I'm going to need this curved area. I'm going to need this area, which is the area of the base of that small cone, and I'm going to need this area, the area of the base of that large cone. The first thing that I'm going to do to help with the calculations is work out what this radius is. And I've got two similar cones, so I'm going to just draw two similar triangles just to help out with finding that. In the small cone, the slant height is 6. What have I multiplied to get from 10 to 6? I could just do 6 divided by 10, which is 0.6. So to get from the big one to the small one, I've multiplied by 0.6. I know the radius of the large one is 3. I want the radius of this small one, so I need to multiply that also by 0.6. 3 times by 0.6 is 1.8. So now that I know my radius of that small circle is 1.8, I can start working things out. I'm going to first work out the curved area of the frustum. To do that, I'm going to need the curved area of the large frustum, take away the curved area of the small frustum. Curved area, I'm going to do the larger one first. It tells me the formula, which is pi times by radius times by the slant height, the diagonal. So I'm doing pi multiplied by the radius, which is 3, multiplied by the slant height, which is 10. 10 times by 3 is 30, so it's going to be 30 pi. Do the same thing with the small one. I've got pi multiplied by 1.8 multiplied by 6. So 6 times by 1.8, which is 10.8. So I have 10.8 pi. So the curved part, large minus the small, is going to be equal to 30 pi minus 10.8 pi. So 30, take away 10.8 is 19.2, so 19.2 pi. That's telling me that this curved part is 19.2 pi. The next thing that I need to do is find the area of this small circle and the area of this large circle. So let's just find out those areas. So area of circles. I'm going to do the small one first. What's the formula for area of a circle? It's just cherry pie delicious and apple pies are 2, so pi r squared. It's 1.8 for my radius, so I'm doing pi multiplied by 1.8 squared. That's my small one. 1.8 squared is 3.24, so 3.24 pi. I'm going to do the same with the large one. The radius of the large one is 3, so I'm doing pi multiplied by 3 squared, which is 3 squared is 9, so it's 9 pi. I just need to add up all of these. So I've got these two areas, the areas of the circles, and I've got the area of that curved bit. So I just need to add up all of these. 19.2 pi plus 3.24 pi plus 9 pi. So 19.2 plus 3.24 plus 9. So it's 31.44 pi. I want it to 3 significant figures, so let's just find out the exact value for it. So I'm going to multiply that one by pi. It gives me 98.771. I'm going to count 1, 2, 3. So I'm looking after this first 7, and this second 7 is telling me that I need to round up. So it's going to become 98.8. That would be in centimeter squared because it's an area.